Hi students, my name is Arvind Raj, Assistant Professor, Department of EEE. In this semester, I will handle the paper EE8010 Power System Transients. Today, we will learn the basic concepts of Power System Transients, Unit 1, Introduction and Survey. First of all, we will discuss what is meant by power system transients. Next, we will discuss what are the different causes and different types of power system transients. First, we will see what is meant by power system transients. Power system transients is nothing but increase in voltage level for very short time in power system is called voltage surge or power system transients. That means a sudden change in the circuit conditions, as when a switch open or close or a faulty occurs on the power system is called power system transients. In this transient period is very short time. And next, there are two different causes occurring in power system transients. That means voltage surge. First one is internal causes, second one is external causes. Okay, next we will see the different causes of transients. Okay, in this diagram represents, we have drawn the graph between frequency and voltage. In normal supply, there is no spikes at a sine waveform. If any fault, that means any over voltages in that particular circuit, the voltage spikes will be generated. Next, if once transient will occur, the results will be blackout in a city, the whole city will be blocked out. And next one is shutdown of a particular plant. If any one of the plant will occur a transient and that particular plant will be shut down. Next, fires in some buildings due to transients. Next final one is unusual power cut. These are the main drawbacks of transients. Next important thing, causes of over voltages, that means causes of power system transients. The causes of transients will be classified into two different types. First one is internal causes, second one is external causes. Internal causes further classified into four types: switching surges, insulation failure, arcing ground, and resonance. And external causes will be occurred on lightning. Okay, first we will see the switching surges. Switching surges is nothing but the making and breaking of electrical circuits. That means open or closing of electrical circuit with switchgear may result in abnormal transient voltages in a power system having largest inductance values and the capacitance. This is called as switching surges. The different situations under which the happens of summarized as ferroresonance, energization of load, and these are the basic situations for occurring the switching surges. In this switching surges will be the over voltage produced on the power system due to switching operation. Already I told, switching operation is nothing but making or breaking of electrical circuits. For example, circuit breaker, if any fault occur on the power system, the circuit breaker will sensing the fault, it will be open to save the load side. Next one is insulation failure. Insulation is the main thing of to protect the electrical components. If any one of the insulator is failed, the system will be damaged. So if sudden changes in the voltage, that means sudden changes in the circuit condition, if insulation also failed due to heating of motor winding or any other changes in the power system. If main thing is, the most common cause of insulation failure in a power system is grounding of conductors, which may causes over voltages in the system. We have considered a line PQ, x is a point of ground, is x is equal to 2E divided by Zn. Both of in this current, both directions, in this both of these currents pass x to the earth, so that the current of earth is 2 into E divided by Zn. Zn is nothing but neutral impedance. E is nothing but voltage. Next one is arcing ground. Arcing ground is a very important thing. In this part, we have the neutral of any one of the system. That means single phase or three phase system. If failure in neutral line, if the over voltage, that means if the fault is increased, the over voltage also increase, so the system will affected due to the transients. In this transient, capacitance are formed between the conductors and ground is very important. And next, this arcing ground can be prevented by earthing the neutral point. Next one is ferroresonance condition. In this condition, resonance causes due to high transient voltage in the power system. In this system, is usual of transmission line. The capacitance is very small, so that the resonance rarely occurred in power system at normal frequency ranges. So, in the ferroresonance is the disturbance that involves high level of over voltages and over currents generation. Okay, this is the main thing. Next, when you load no load, that means a no load capable connected transformer is disconnected from the source, over voltages and current also generated. This is a unloaded transformer. Means if any one of the transformer is unloaded, the over voltages will be generated, over voltages and currents also generated. Next one is capacitor is discharged to transformer primary winding, then the ion core is saturated due to ferroresonance in transformers. Next one is external causes. For example, lightning. This is the major cause of transients. First, lightning is nothing but it is a arc development. That means the lightning will be occurred by using cloud discharges. First one is equipment due to lightning, the equipment damages and failures. And next one is voltage sags, damages to customer electronic devices, and total supply interruptions. These are the main drawbacks of lightning. And these lightnings, that means the external over voltages are classified into two types: direct lightning stroke and indirect lightning stroke. Direct lightning stroke means if the lightning directly fall on the transmission line is called the direct lightning stroke. And next one is types of power system transients. In this power system, transients are basically classified into three types. It depends upon speed of transients. First one is ultra fast, medium fast, final one is slow transients. Ultra fast transients is nothing but is caused either by lightning or by the updraft. This is the main thing. In this transient, entirely electrical in nature, so it will be last only generate a few milliseconds. So in this such transients give rise to high voltages, that is much higher than the nominal system voltage. And next one is medium fast transients. In these transients occur due to abrupt short circuits in the system, causing abnormal structural changes in the system. That means in these transients are also entirely electrical in nature. In this short circuit, transients may be present in the system for longer period. That means 10 cycles of power frequency source voltage. Next one is slow transients. In these slow transients are electromechanical in nature. So in these transients occur by using mechanical oscillations of rotors of synchronous machines. So in these oscillations may cause instability of the interconnected power system by putting some or all of the machines out of the synchronization. Next, further classified in the transients depends upon source, means the switching transients and lightning transients. And next, it depends upon nature. We have classified into two types: impulsive transient and oscillatory transients. In this impulsive transients, further classified into nanosecond, microsecond, and millisecond. Nanosecond means it will rise only 5 nanoseconds, and microseconds only the transients will rise 1 microsecond, and millisecond transients is nothing but it will be rise 0.1 millisecond. Next is the oscillatory transient. In these transients further classified into three types: slow transients, medium, and high transients. In this oscillatory transients, it depends upon the range of frequency. So the slow transients will occur in the range of frequency is more than 5 kilohertz. And next, medium transients, that means medium frequency transients occur the range of 5 to 500 kilohertz. And next, high frequency transient, in this transients occur will be in the range between 0.5 to 5 megahertz. Okay, next, what is meant by impulsive transient and oscillatory transients? In this impulsive transient, it is a sudden non-power frequency change in the steady state condition of voltage and current, both, that is unidirectional in polarity. The basic difference between impulsive and oscillatory transients are, in impulsive transients it's a unidirectional one, and oscillatory transients are bidirectional. That means it includes both our voltage and currents, or both includes both positive and negative polarity. So the example of oscillatory transients are capacitor bank energization. Okay, next important topic is protection against over voltage. There are further divided into two types. First one is shielding type, second one is non-shielding type. In this shielding type will protect against external over voltages due to lightning strikes. So in this system we have to rectify by using ground wires, earthing screens and surge absorber. Next one is non-shielding method. In this method protection against only for internal over voltages, and also it can be used for protection against lightning strikes. For example, for non-shielding methods are sparking gaps and lightning arresters. Okay, thank you.